Hello. Today we will be seeing about the control structures in R programming. So what exactly do you mean by control structures? These are like which will allow you to control the flow of execution of the program. For example, if you have some experience in programming, you will know about if else, for loop, while loop, repeat, break, those kind of things. So those are actually it controls the flow of the program, where it goes, how much time a module should run, those kind of things. So the common structures in the common control structures are if else condition. So these are conditional modules. For loop is like, again, it's a conditional module, it's but it loops for a fixed number of times. And while loop, again, it's same as for, but there is slight differences, I'll tell you later. And there is a control structure called repeat, which will execute in an infinite loop. And there is a break. This can be used in any loops where you want to stop the execution of the program. And next is a special type of keyword which will help you to skip an iteration of a loop. For example, if you're using a for or while statement, if you want to skip for a specific flow, you have to use the word skip. You have to use the word next, which will allow you to skip an iteration of a loop. And there is a return function which actually returns to the previous function that called the internal module. So most control structures are not used in interactive sessions, but rather when writing functions or longer expressions. Moving on, we are seeing about the control structure if. So the normal structure syntax for if is like if the condition, then do something else, do something else, then if condition, do something else if condition. The next one is your if else if condition, else if another condition, do something different, and if there is nothing else to do something different. This is your control structure. So this is a valid if else structure. I'll not be doing this in our module right now. These are simpler structures, so I'll leave it to you guys to do it on the R module. So for example, this is a valid if else structure. If x greater than 3, assign y equal to 10, else assign y equal to 0. So the next one is next another example. So if y equal to if x greater than 3, you are assigning the value of x. This is just a different way of writing the previous function. So if there is like if x is greater than 3, assign it to y, uh, and then in the loop it will have 10, else 0. So this will have, if let's say for example there is a value of x equal to 4, 10 will get assigned to y, else 0 will get assigned to y. That's all. So the else clause is actually not necessary if you are going for only one condition. So if there is one condition, you can use if condition 1 yes, and if condition 2 yes. These are just simpler things which you will not find in the previous programming languages, other programming languages. The next control structure is for. For loops actually take an iterator variable. For example, you can use iterator variables such as I, j, k, and assign its successive values from a sequence or a vector. For loops, for example, in C or C++, you will be using for loops to iterate across arrays, iterate across linked lists, those kind of things. So for loops are most commonly used for iterating over elements of an object. For example, if there is a vector called I, and there is a vector with 1 to 10 variables, and you want to print all those 10 variables. This is what is given here for I in 1 to 10. You just print I, it will iterate. For the first value of I, it will print I1. For the second value, print I equal to 2, print 2. It So the loop takes the I variable, and in each iteration of the loop it will give the value 1 2 3 etc up to 10, and then it exits. So here again we are giving you an example. So for x, you have values of an array for a vector a, b, c, d, and so for I in 1 is to 4, print x of I. So this I value gets changed between 1 to 4. So for example, here 1 to 4, print x of I will give you a, b, c, d. X of I is, x of 1 is a, x of b is b, x of 3 is c, x of 4 is d. So for in sequence along x is again a special function in R programming, which will again it will give you, it will iterate from it will follow the perfect sequence from a variable, beginning variable to the end variable. Again, you can use print letter in x, for letter in x, print letter. That is also possible. A letter will iterate from the beginning of the vector to the end of the vector. So again, the last one is our simpler one. For I in 1:4, print x of I. Moving on. So nested for loops. So what are nested for loops? Like, there is a for loop and you want to write another for loop within it. So that is nested for loops. Nested for loops are most commonly used for matrices. So here you have a matrix called X, which contains two rows and three columns. So which has values 1, 2, 3, 4, 5, 6. So we have for I in sequence length of n row of X, number of rows in X. So for the first row, for the first column, second column, third column, you are printing the values, and the next row for the first column, first column, second column, third column, you will be printing the values. So you should be very careful with nesting. Actually, nesting beyond 2 3 levels is often very difficult to read or understand. As you can see, for matrices, if you only when you write it down you will understand what happens here, but other than that it is very difficult to understand this. Next control structure is while statement. While loops actually begins by testing a condition. So if it is true, if the condition is true, then they execute the loop body. Once the loop body is executed, the condition is tested again and so forth. For example, count less than 0. So while count less than 10, print count plus 1. So what here happens here is when the count is less than 10, you're just printing the count. So and then what happens, you are incrementing the count variable. Initially the count starts with 0. So the next, when the variable is goes into the loop, count less than 10, it's 0, so it goes into the loop and it is incremented. The count value becomes 1, and again it comes to the loop. Count is greater than less than 10, so again it goes into the loop and goes on till it prints 10. 10 it will go on, and after that when count is less than 10, so if it is less than till count 9 it goes on. 9 is less than 10 will get printed, and count value will be 10. After that when you test count, you'll the loop will not run. So while loops can potentially write in infinite loops if not written properly. Again, like you should be using it with care. You should be familiar with the conditions what you are using the while loop for. And this is an example. So we can test multiple conditions in while using while statements. Sometimes you can use multiple conditions. For example, here is it less than 5, so you are testing for two conditions here. When is it greater than 3 and is it less than or equal to 10, you're just printing is it, and you are just creating a binomial function here. I'll tell you later. So you are just assigning z equal to z plus 1, else is equal to z minus 1. So this loop goes on testing for the conditions, incrementing z values. So and the conditions are always evaluated from left to right, as most of the human languages. And then we are seeing repeat. So repeat actually creates an infinite loop. So like these are not commonly used in statistical applications, but they have their uses. The only way to exit a repeat loop is to call break. You should inside a repeat loop you should have a condition and it should call break. Otherwise, the loop might run continuously and it will take up your processor capabilities, everything. So we have a value x0. We are assigning the value 1, and we have one more variable 12, and this repeats x1, which is like log of -8, and compute estimate. If absolute value of x1 minus x0 is less than 12, then break, else x0 is assigned x1 to x0. So this is how the repeat works. It will break whenever you want to break the statement, you have to use the condition break. So it is a bit dangerous because there is no guarantee it will stop. better to set a hard limit on the number of iterations. For example, in the repeat, you can just set a count variable for how many times, maximum number of times or minimum number of times it should run, and then just finish it. Whenever the loop tends to run infinite, using a count variable, you can stop the repeat function, the repeat statement. So you should set a hard limit, that will be a safety measure, and then report you can whether the convergence was achieved or not. And there are like the next thing is the next and return. Next, as I told you earlier, which will be used to skip an iteration of a loop. For example, I don't want the first 20 iterations to run when I'm running the iterations from 1 to 100. I don't want 1 to 20. I want to start it from 21 to 100 only. So if I is less than 20, I'm just using next. So it will skip the iteration, and it will start only when 21. You can use this I less than or equal to 20 condition for any number of any kind of conditions you can create using that. And return signals that a function should exit and return a given value. Return, actually, it's it's used in functions which will just return some values to the function that calls the inner function. And control structures, I am giving you a summary of it. So we saw the control structures like if, while, and for allow you to control the flow of an OR program. Infinite loops should generally be avoided, even if they are theoretically correct, because this will take up all your and this will be running infinitely, and it will occupy all your programming. I mean your processor space and processor memory, and this will create unwanted issues in your system. And control structures mentioned here are primarily useful for writing programs. For command line interactive work, and apply functions are for the apply functions are more useful. I'll tell you about the apply functions a little bit later.